today's session, we will be discussing upon various elements in detail which are the part of remote sensing. Among different components, the first one is energy source and illumination. As we know, the source of energy to illuminate the objects are very much necessary for the process of remote sensing. And the source of energy is acting as the medium of transformation of information about the features from the Earth's surface to the sensors, which are for the purpose of capturing the information about the Earth feature. So, based on the energy source itself, we can divide the remote sensing process into two types. One is active remote sensing, another one is passive remote sensing. The passive remote sensing is nothing but the source of light energy is natural sunlight. But the availability of sunlight is only during the day hours. But during the night hours also the sensors are capturing the information about the earth's surface. This is through the this is through the artificial light which is producing by the sensors itself. If the light energy is producing by the sensors itself of remote sensing is called as active remote sensing. Active remote sensing or this type of sensors will be working or capturing the information about the earth features throughout the day, irrespective of day and night, and it will be working in different seasons also irrespective of various climatic conditions. Now, in detail, we are going to study about the energy source, as I said, which is the carrier of information for the remote sensing process. As we total seven rays are present in the sunlight, starting from gamma rays and ending with the radio waves. These all seven waves are arranged as per their wavelength and frequency and also speed. These arrangements of the light rays are called as electromagnetic spectrum. The spectrum is starting with the gamma rays which are having the least wavelength and high frequency. The other end of the spectrum is arranged with microwaves and radio waves which are having high wavelength and less frequency. These waves arranged in the spectrum as per their frequency and wavelength. One end you can able to see gamma rays which are having very less wavelength but high frequency, and another end radio waves which are having high wavelength and less frequency. Here the wavelength you can able to see towards the radio waves wavelength is increasing, and on the bottom frequency is increasing towards the gamma rays. As all of us knows, these waves are having different properties also, and they are having different applications also. We will look into the application of each waves. Gamma rays have the shortest wavelength and highest frequency in the electromagnetic spectrum. Because of their great penetrating ability, gamma rays can cause serious illness. But when used in controlled condition, gamma rays is useful in cancer treatment as well. It will kill cancer cells, study the nucleus in atoms, making pictures of the brain. Gamma rays are the highest energy electromagnetic wave. In the electromagnetic spectrum, as you observe, the next ray is X-ray, which is having wavelength of 0.01 nanometer to 10 nanometer, which is used for the detection of fractures in bones, used for studying atomic arrangements in crystals and complex molecules. Next one, UV waves or ultraviolet waves. UV light that is at a higher frequency and energy. UV light have high wavelength compared to gamma rays and X-rays which is 10 nanometer to 100 nanometer. They cause health hazards like skin cancer. UV radiation is used in hospitals to sterilize the surgical instruments because they can kill microorganisms. Too much exposure can cause sunburn skin cancer because of the damage of cells in DNA. Next one is visible light. As we all know, among the total seven rays of sunlight, only the visible light are the portion which can be detected by the human eyes. The visible light itself is again divided into various rays based on their characteristics. There are seven rays are arranged in the electron in the visible spectrum also. Here you can able to see in the total in the total electromagnetic spectrum after UV light and before the infrared waves there is a special the human detectable visible rays are present which are again divided into a small spectrum which is starting from violet to red based on their wavelength. And visible lights are enable us to see the things, and it is also useful for photosynthesis in plants. All the waves are having different range of wavelength. It is mentioned from violet to red. Red is having highest wavelength as we already know, and violet is having less wavelength compared to other waves. Moving on to the next waves, infrared waves, which are having wavelength 700 nanometer to 1 millimeter, which is used in the photography at night and also in mist and fog as they have less scattering. Using in television remote control and other gadget. It is invisible to human eyes, but people can feel it is as hot. Infrared waves are heat waves. Next one, microwaves, which are having wavelength from 1 millimeter to 1 meter. Because of high wavelength, it is using for the satellite communication and it is also used in the cooking in microwaves. Used in the which is using in the cooking in microwaves, micro oven. Analysis of fine details of molecular and atomic structure. The last one is radio waves, which are having highest wavelength and less frequency, and which is having wavelength for at the range of 10 meters. These are used mainly in radar communication and in the radio and television communications, which is having the lowest frequency. The radios converts the electromagnetic waves into the sound that comes out of the radio speakers. These are the details about electromagnetic waves. So students, in exam you will be getting a question like explain electromagnetic spectrum with a schematic diagram. You are supposed to draw this detailed diagram and if possible by heard the wavelength and frequency, and you can show that also. Then you are supposed to write down the characteristics and applications of each wave also in order to score the full marks for the question. And here the visible rays are also required to show separately. Thank you everyone. The next part we will be continuing in the next class. Moving into the next component of remote sensing process, that is radiation and the atmosphere. In this component, we are going to study how after the production of electromagnetic energy, it has to pass through the atmosphere before reaching to the Earth's surface. Here you can able to see in the diagram, here sunlight, the energy is producing, the light energy is passing through the atmosphere before reaching into the Earth's surface. So in between, this is important part, the light energy is passing through the atmosphere. Through this transferring through the atmosphere, what are the different processes which is happening to the light energy we are going to observe today? Interaction of electromagnetic radiation with the atmosphere. Here you can able to see the light energy once it is produced, it has to pass through the Earth atmosphere before reaching into the Earth's surface. Here, in between, the light energy is undergoing mainly two types of process, that is scattering and absorption. After scattering and absorption, some light energy, or what is the light energy which is not undergoing scattering and absorption, will be passing through the atmosphere and reaching to the Earth's surface. This is the process which is happening to the light energy when it is passing through the atmosphere. This diagram is very important and it is very simple also. As you can able to see, the light energy is getting produced and it is transferring through the atmosphere before reaching into the Earth's surface. Here it is undergoing various processes like scattering and absorption based on the atmospheric uh, constituents which are present. We will study in detail now. Scattering, which is a redirection of electromagnetic energy from its original path. Absorption, a retention of electromagnetic energy by molecules which are present in the atmosphere. Transmission, passing the electromagnetic energy through the atmosphere and reaching to the Earth's surface. First one, scattering. As we all know that in the atmosphere there are various particles are present. Like there will be water molecules will be present, there were various clouds, and there will be various dust particles will be present in the atmosphere. Once the electromagnetic energy is produced from the sunlight, when it is passing through the atmosphere, because of the presence of various constituents like clouds, dust particles, and water molecule, the light energy is getting diverted from its original path. That diversion of light energy from its original path to some other direction is called as scattering process. The light energy is getting diverted because of the presence of various particles which are present in the atmosphere. As you can see here, the light energy is getting produced, and here on the way to the Earth's surface, here you can able to see because of the presence of the dust particle or water molecule, it is getting diverted into various directions. So this light, that part of the light energy, it will not be reaching into the into the Earth's surface. Then the second process is absorption. Before starting absorption, we have to look into the types of scattering which is happening in the atmosphere. Based on the way the light energy is getting scattered, there are two types of scattering is happening: selective scattering and non-selective scattering. Under selective scattering, there is another two types are there: are relay scattering and mean scattering. Then we will have a discussion on non-selective scattering also. First one, relay scattering. When the particle causing the scattering are much smaller in diameter, that is less than 1 nanometer, than the wavelength of the radiation interacting with them, then this is called as a relay scattering. So when the light energy is produced from the sunlight, when it is passing through the atmosphere, if there are any particles which are having the diameter less than 1 nanometer, that is when the particle causing the scattering are much smaller in diameter than the wavelength of radiation. If the particles, it may be the water molecule or it may be a dust particle, whatever it may be, if the diameter of that particle, if it is less than the diameter of electromagnetic energy, electromagnetic radiation, then it is called as a relay scattering. Now the next one is Mean scattering. That is, the wavelength of the energy is almost equal to the diameter of the atmosphere particles. Then non-selective scattering. When the diameter of the atmospheric particles are much larger than the wavelength being sensed, caused by the water droplet especially. Here in this table, I had also mentioned which are the particles which are causing each type of scattering. The relay scattering, it is mainly causing because of air molecules. So as we already studied, the air molecules which are having smaller diameter than the radiation which cause the relay scattering. The mean scattering is smoke and haze which is almost equal to the diameter of the electromagnetic radiation. Then the non-selective which are more than based on the diameter than the electromagnetic radiation which will cause the non-selective scattering. Then the next process which is happening to the electromagnetic energy when it is passing through the process is absorption. Absorption, as I already told, it is a retention of electromagnetic energy by the molecules which are present in the atmosphere. There are different three constituents which are absorbing the part of electromagnetic energy from the radiation. These are the different components. These are the different constituents: ozone, carbon dioxide, and water vapor. The ozone, which absorb the harmful ultraviolet radiation from the sun. Carbon dioxide, which will absorb radiation strongly in the infrared portion of the spectrum area associated with thermal heating, which serves the trap is heat inside the atmosphere. Then water vapor in the atmosphere absorbs much of the incoming long wave infrared and short wave microwave radiation. So while looking into these components, you might got idea that because of the presence of these components, most of the infrared rays or the heat energy is not coming into the atmosphere because most of the heat energy is getting absorbed by the water vapor and the carbon dioxide. And also the ozone layer which is protecting the earth's surface from the harmful ultraviolet radiation. And the next one we are going to see how the absorption which is happening to the light energy based on a schematic diagram. Here you can able to see the x-axis which is mentioned with the wavelength and the y-axis is the intensity of energy. So here the ultraviolet rays, which is most of the ultraviolet rays are absorbed by the ozone. Here it is mentioned as ozone, and here as the wavelength is increasing towards the right side. Here you can able to see as the wavelength increases how the different constituents are absorbing the different radiations which is present in the electromagnetic energy. And here the visible portion of the light is also getting absorbed by the different components like ozone, carbon dioxide, and water molecules. And towards the right side, you can able to see as the wavelength increases, that is towards the infrared waves, the carbon dioxide and the water molecule absorb most of the light energy, which saves the less heat energy availability or transferring to the earth's surface. This diagram is also very important along with the explanation of this absorption which is caused by the different components. This schematic diagram also should be shown, which will give more clarity about the absorption based on the wavelength of the light. Next one, transmission. After the scattering and absorption, there will be some part of the light which is directly coming to the Earth's surface without any disturbance. That part of the light energy is called as transmitted light. So, how to calculate the transmission? It is a very simple empirical expression is shown here. Transmission is equal to transmitted energy divided by input energy. From the input energy, how much is directly transferring into the Earth's surface, that is transmitted energy. If we do this, we will be getting what is the transmission happened. There is a small term called atmospheric window. Atmospheric window is nothing but among the total energy. What is the portion of the light which is not getting affected severely by absorption and scattering? That part of the spectrum which is directly coming into the Earth's surface is called as atmospheric windows. The wavelength at which the electromagnetic energy are partially or wholly transmitted through the atmosphere are known as atmospheric windows. Thank you everyone. We will be continuing the next component in the next class.